Now, so for our next session, we're starting our session 2, which is transforming the bioenergy opportunities into results. So, if I can ask, our first speaker on this session from Board of Móna is Paul Schütze. Paul Schütze is the Senior Commercial Development Manager of Board of Móna's Renewable Energy, and will be discussing Board of Móna's vision for bioenergy carbon capture and hitting net zero. Paul is a Senior Commercial Development Manager with B&M. Being a member of the commercial team within the Renewable Energy Business Unit, he's responsible for the development of Board of Móna's Edenderry Eco-Energy Park. The development of the park looks at various opportunities, including green hydrogen, carbon capture, and the facilitation of large energy users. So Paul, if I can ask you to join us here. Thank you.
Yeah, good morning, everyone. Thanks for the kind introduction. First of all, thanks to IrBEA's for organising this event and for having us here to talk to you all today. I'm conscious, it's literally just a coffee break there, so please feel free to keep enjoying a cup of coffees. I'm gonna be talking about something that is a little bit further out in the future. We have heard a lot about the near-term future when it comes to bioenergy in Ireland. We have heard a lot about biomethane, all the various different projects that are out there. We have heard about what is required to get this industry going. I'm here to talk about a little bit more in the future, further future. What is the vision? And I particularly want to focus on potential carbon capture of bioenergy in a net zero power system. So I'm going to start with something that I'm always advised to not to start with, which is a graph. Now, what gives me confidence is that we have seen a lot of graphs already today, so I'm certainly not the first person to pull up a graph. I'm not going to bore you with details on this, but there's a lot of talk about European net zero energy system. But what does that actually mean? So, as you can see here on the graph, this is basically our pathway to 2050. This is from a report that the European Commission issued. It's called Our Zero Emission Future. And they basically map certain scenarios for certain temperatures and how do we achieve those scenarios. So I chose the 1.5 degree scenario. And what you can see here is basically the greenhouse gas emissions over the time up to 2050 and the various different industry sectors. So we have spent a lot of time talking about kind of the near-term future and what are we going to do to reduce carbon emissions in those next 20 to 15 years. What I want to focus on is two particular things in this graph. The first one is this line here. This line here is basically, and again I need to highlight, this is kind of a European report. So in 2040, if we want to hit the 1.5 degree scenario, we need to have a fully decarbonized power generation system. So the very, apologies, sorry. So the very top column here is your greenhouse gas emissions from power. They basically essentially go down to zero in 2040. So that's the first milestone that we need to achieve, right? Which is very ambitious because that's only 16 years to go, as everybody knows. The other point that I want to point out from this graph is this section down here. And this is what this presentation is going to be about. So not only, and as everybody knows, a net zero energy system doesn't mean that everything has to be fully decarbonized. It means that the overall balance in our energy system needs to be zero. There will always be elements within every single part of industry that will emit carbon. So in order to get to a net zero system, it's logical that we basically need to remove carbon again. And there's certain technologies out there that we're going to focus on. What is interesting here is basically just to look at the size of this triangle here. This is actually quite significant in scale. This is 1 million tons on the y-axis there, so it's quite significant. So when we look at negative emission technology options, there are several out there. But I think there's basically mainly 4 options that we can look at. The first one is direct air carbon capture that you see on the top left. It's basically as simple as a big fan that is sucking in air and is taking out the carbon. You can then store it. To be honest, it's very early days. The technology works and has been proven, but it's very, very energy hungry. So at the moment, to capture a ton of carbon, it's actually quite expensive. So this will certainly play a role in the future, but right now it's quite a tricky one actually to scale up. We have natural sinks, and we obviously had a presentation on this earlier that was focusing on forests. Obviously representing Móna here, we also need to talk about peatlands when it comes to this. So natural sinks are great. They can basically sequester carbon by growing peat over time and capturing that carbon and trapping it in the soil. It's very difficult to actually quantify the amount of carbon that can be sequestered as a part of those natural sinks. So every single bog is different. So there's great studies being carried out at the moment to actually put a number on this. But again, it's quite difficult to put a number on it. There's the biogas or biomethane carbon capture market. That certainly is going to play a key role in the near future when it comes to negative carbon emissions. And then there's the biomass carbon capture piece. You see a picture of Edenderry here in the background, and this is obviously what I'm going to focus on over the next few minutes. So what is the opportunity at Edenderry? As Tom alluded to earlier, and we're going to see further information by Joseph later on this, but essentially Edenderry Power Station is now running on 100% sustainable biomass. The last bit of peat went in there at the end of last year, so in the eyes of an accountant, it's basically carbon neutral. Obviously, it is still one of the largest single point sources of biogenic carbon in Ireland. Biogenic means basically it's sustainable carbon that is coming out of the stack. Essentially, it's the same molecule, though, as any other power station would emit. When we are talking about the volumes that the plant kind of emits, Tom again mentioned a number there earlier. It really depends on the running profile of the plant, and I'm going to come back to that point later on. But essentially, we can capture up to 500,000 to 1 million tons of biogenic carbon per year at that plant. Now, just to put that into context, we believe that in our energy system, in a net zero energy system, we'll still need to have about 10% of the time the electricity will have to be generated by gas or thermal, in a thermal way. So you can either use green hydrogen for that, you can use biomethane for that, or the other way of doing that is you basically offset those carbon emissions by doing something else. So the last 2 million tons of carbon that are to be removed from the power generation sector are actually going to be very difficult and capex intense to remove. If we were to capture carbon up to 1 million tons here, that could offset the power sector directly. So it's kind of a, it's this balance approach, I suppose, that we need to look at. When you're capturing the carbon, you can do different things with it. So the first one is you can permanently store it on the ground. There's different options there, different avenues are being explored. Then you obviously turn this plant into a carbon negative plant. So basically you capture the carbon, you put it on the ground, and you leave it there forever. The other way of what you can do with that carbon is to utilize it. So you can basically utilize it to produce an e-fuel, for example. Sustainable aviation fuels, a lot of people are talking about that. It's very early days, I believe. But at the same time, there's mandates out there by the EU that we need to follow. So there's those two different options. We at Móna have actually looked at that. We commissioned a study there at the end of last year that was basically looking at the site and looking at, is it actually doable? Can we actually capture the carbon on site? And could we potentially produce an e-fuel there on site as well? That work has been completed at the end of last year. It was a very, very positive report. Now, I appreciate it was high level, but in general, it was very, very positive. It said, yes, absolutely, we can capture the carbon there, but also we can produce e-fuels there if that's the route that we want to go down to. Now, this is the opportunity for Edenderry and for Móna, but I do believe that there is kind of another step to this. If we need to look at it in a little bit more holistic approach, I suppose. So now I'm going to talk about the vision. And I appreciate this seems to be far out there, but these things are really capital intense. So if we want to make these things happen, we have to start them now. So what I'm going to be talking about now is a carbon cluster in the Midlands. So far I've spoken about carbon capture at Eden Dairy, but isn't there an opportunity to actually do something more to this? So I took a little screenshot here of Google Maps of the Midlands. Appreciate it's only a small, tiny section of Ireland. But what we see here is that there's a lot of industry around that Midlands area. So on the right-hand side, you see Eden Dairy, you see our peaking plant down there as well, you have road power generation, you have the cement industry there as well. All of these industries are big carbon emitters. So if we start capturing carbon, why shouldn't others? When we engaged with industry, everybody has plans to capture the carbon because that's the way the industry needs to move. We have to reduce our carbon emissions and potentially turn them into negative carbon emissions. So rather than all doing it on our own, what we are saying is, why shouldn't we develop all this together? So yes, everybody would need their own carbon capture facility on site, but then isn't there an opportunity to develop a carbon cluster somewhere in the Midlands where you basically combine all the carbon that is captured and utilize it together? So what exactly is the opportunity here? I suppose there's numerous of positives and advantages there. I'm going to focus on three advantages, because I think that they're going to be key. The first one is that it is an opportunity to collaborate between all existing industry partners that are working in this area already. If you're developing infrastructure together, it's obviously, first of all, cheaper, even from a development point of view. But also, we can use that infrastructure together and therefore increase the utilization factor. When we increase the utilization factor, again, it makes it a lot cheaper to run. It's the same as, people sharing cars. Rather than everybody buying their own car and then driving it whenever the person needs it, why don't we share it and get a higher utilization factor out of this and therefore reduce costs for everybody? The other element, and this is probably the key, is the one at the top left. I truly believe that once we develop something like this and develop a carbon cluster, let's say, it presents a massive opportunity for any future industry in this area of industry. So basically, if the carbon infrastructure was there, if there's a new industry partner coming along and said, yes, this is where I want to locate in the Irish Midlands, it's a lot easier for them to tap into that existing infrastructure. It is a lot easier for them to actually make a business case for a carbon capture plant. So if we were to develop this, the infrastructure is there. If there's another new partner coming in, they could basically just tap into the infrastructure. So it makes a lot of sense from that point of view as well. Now, and this is probably the drawback again, I think everybody has probably a very similar spin in their presentation, but there is obviously certain requirements to make this happen. First of all, on-site carbon capture is very capital intense. Just to give you an idea, when we looked at it from an Eden Dairy point of view, it's basically a second power station next to the existing power station. So it looks fairly similar. You have an absorption tower that is similar in height to the stack. So it kind of gives you an idea of scale that is required to actually capture the carbon. What comes with scale is capex, so a lot of capital expenditure. So it's very expensive. The other issue for us developing a business case for this is that the carbon ETS price is very volatile. So it basically goes up and down. At the moment, it's actually quite low. People didn't think it's going to be this low. There's a lot of uncertainty around the carbon price in the near future. When you're developing a project of that scale, you're basing it typically on a kind of 20-year business case. So you need to have a certain amount of certainty on the price of carbon that is basically ultimately the payback that is affording the project. Just to give you an idea, on the right-hand side, you may not see the figures, and it doesn't really matter, but it's basically just, this is the forecast that Aurora issued when it comes to carbon prices. What I want to show here is basically the three different scenarios. So they have a central scenario, they have a high scenario, and they have a low scenario. What is interesting is in 2060, the difference between carbon prices between those three scenarios is from the top, which is roughly 250 euro per ton, down to 90. Now you can imagine how difficult it is to build a business case over the course of 20 years if there's so much uncertainty there. So the easy way to bridge that issue is a support scheme that we're all very familiar with, which is a CFD, Contract for Difference support scheme, that can reduce that uncertainty and provide a clear route to market strategy for business developers. Just for people who are maybe not familiar with the CFD model, it's on the left-hand side. It's very, very straightforward. So you have the cost, CO2 abatement cost. In this particular case, it's for steel production, which we funnily enough don't have in Ireland, but I thought it was a good example anyway. So in this case, it's 120 euro per tonne. You have your ETS price, which at this point in time was 50 euro per tonne. So you have a gap there. And this gap can be bridged by a government guarantee, similar enough to what you see in the electricity sector. Now, that obviously can go both ways. So there's two-way CFDs as well, so that's capped at the top as well. If we look at the cost for carbon and carbon prediction prices in even, I think it's 2030, you're getting very close to the 120 euro there per tonne already. So it's certainly a mechanism that we believe would work really, really well. Now, that's just talking about the carbon infrastructure on site. What I mentioned before was this cluster infrastructure. That probably requires a different funding mechanism, I suppose. So that could be different pipelines that connect different carbon emitters. That could be virtual pipelines. There's various different options that are there. They probably require additional significant support, or could even be built as state-funded assets. We are open to any help on that and discussion on that. What I would like to end up with, I suppose, is one picture that I really think summarizes the industry quite well at the moment. It's taken on one of our peatlands there. I do believe that there is a world out there, a wide world out there that is based on bioenergy and renewable energy. It's going to be a very tricky road. It's a long road. We have a long road ahead of us. It's bumpy, as the track suggests, so it's going to go up and down. There's going to be curveballs in the way, but I do believe if we all pull into the right direction, we can get there. Thank you very much.
Thank you very much, Paul. So next I'd like to invite up our CEO, Sean Finan, who is going to